being part of this. So, Katie, what are you thinking about doing for your final project?
I sorry, I have to look up back at our email. I was thinking about doing something with Iowa. Give me a second to
Oh,
pull
no
it up.
worries. Yeah, a lot of people compare Iowa to some national statistic, right?
Which is one I wanted to do um with like podcasts, but I couldn't find like anything.
Oh, yeah. So I mean, what I like is that people kind of pick something that they're interested in, go see if they can find some data sets that they could use to do the analysis. And if nothing comes up, like you're like, I can't find anything that shows the Iowans' participation in podcasts, right? Or percentage of that. So then you have to tweak it. Now, usually when you're out looking around for stuff, you'll come upon certain, statistical things or data sets that people have published that may lead you to a related question. Has that happened yet?
Not really. I feel like podcasts are pretty new. So when I look up like Iowa podcast usage, it just shows up the best podcasts from Iowa.
Yeah, like it doesn't have like how many or how what percent of the population. Yeah, I was doing podcasts with my little, oh, what was that little thing called? Is like, I think it ended up being the last Guardians of the Galaxy. Like he upgraded from his Walkman to his little i I don't know, what do they call it? iPod. It's an iPod essentially. It was really old. Is it like, I think I was doing those in about 2004. I was listening to stuff on those, which is a long time ago. It was even before YouTube. So I like the idea of podcasts. One thing I want to show you, and this will benefit everybody, I've posted a document in this folder that has example data sets that students have used in the past. It's kind of like a curated list that we keep updating. So I'm going to go ahead and share my screen so you can see that real quick.
Which that's the one that you sent me earlier, right?
Yeah, but I put it in the course. So I want to show everybody. All right, can you all see my screen now?
Yeah.
So in week 13, I've added this examples of data sets you could use for your project. And then this is a Word document you can open up, and it might give you some good links. All right, can you see all that? Ooh, I just messed it up probably. There, it's over here. All right, how about now? Do you see it?
Yeah.
Okay, so like I have a lot of nursing students, so here's about stuff about CNAs, U.S. Census Bureau, COVID, college costs, graduation rates, teachers. So this is just a really quick list. We keep adding to this, but I thought, I'll throw this out what I've got right now to just give examples of where you might go find some data sets. There are a whole bunch of other ones that I probably should add to this, but this is a good start. But if you find a good site, or if anybody who's watching this finds a good site that they thought other people would benefit from, it's got good data sets, send them to me, and then I'll add them to this, okay? That's all I want to show you. So what I would suggest is you were doing podcasts, right? So what you might want to do is if you could find, what might be neat is if you can find a research study that shows the difference between certain demographics, for instance, male or female, or different age groups. Who does podcasts? How long do they, on average, listen to them a week? I'm sure there's some marketing data out there that shows like, somebody in age 15 to 25 versus 25 to 35, something like that, that would show um, like how long or how many podcasts that people go through. Because I know marketing people always want to know that so they can sell ad space. So maybe that might be another thing you can compare between two demographics. Does that make that word demographic make sense? Like old versus young,
Yeah.
maybe, you know, maybe socioeconomic status, maybe even race or geography or something that you could show, hey, people in the Midwest or compared to the coasts or So I don't know if you want to stick with that podcast idea. That's kind of I think it's kind of cool because like I think they've kind of exploded recently,
Yeah.
and like everybody's doing them. I'm even in one, so I'm like, yeah, I guess that's a very interesting study. So have you found, where did you find that national
Um,
source, that national data set?
I have
Or
it.
just,
I have to find my document with it.
yeah, so it's probably just like an article, right, that had like a link
Yeah.
to, right. So usually you can tunnel through that and actually find, the more specific data, like how many people did they survey, what was the percentage, stuff like that.
It was convinceandconvert.com is where I found it.
Okay. So on that one, you might see if they have related data sets, because I'm not sure, whenever they try to take a survey of like America, it's a really hard thing to measure. And
Yeah.
typically they got to get at least 1,000 replies or submissions to get the confidence interval. You remember doing, you're starting to, you remember doing that for confidence intervals for proportions, the sample size required. You usually need about 1,000 for proportions to keep it within a 3% margin of error, which is typically what you see like in presidential polls or whatever. So if you're analyzing percentages, you just pretty much need the number of occurrences, n, and how many were successes, and that gives you enough information to plug in the formulas. If you're comparing two proportions, obviously both those. If you're doing means, like let's say average length of time, you would need the mean, and you also need the standard deviation. That's the thing people like, oh, I saw that people on average watch 42 minutes of podcasts a week. Great. But you also need the standard deviation of that data, which means you have to tunnel a little harder. That's usually a little thing that people forget, because you got to know how variable that is, right? How much spread there is in that data. The standard deviation describes the spread. Cool. I don't know if
So
that helps you a ton, but maybe it points you in the right direction. I mean, we've got a little over a week till we kind of like to have it submitted, right? I think once you start the write-up, it's not that bad. You got your idea, your question, your null and alternative hypothesis, do your analysis, interpret it, do your confidence interval, post your results, screenshots, put it in a Word document, and then you just make a little video like you did before, kind of explaining. It can be even really short. It's like, hey, I did this thing on podcasts, and my question was, do young people watch them more than old people, or something like that?
okay.
And you just explain, and here's what I found, and here's the p-value, and then everybody can kind of quickly just go through everybody's stuff and watch a little quick video on everybody on their results.
I'm trying to find like where they got all of this data from.
Okay,
Not
cool.
working very well.
Yeah, that's the way to do it. And sometimes they're more forthcoming than other times, right? Sometimes these like they'll
Yeah.
have a link that, oh, this is where I got it, and here's the survey results, and other times they're just like hiding it.
Okay. That's,
And once you kind of get the question in the data set, you can just go. It doesn't take that long to do it. But that's why we like to start it and give you like, over 2 weeks or 2.5 weeks to really work on it, so you can kind of wrestle with these things and see what's out there. And if you need to tweak it, that's fine, no big deal.
so it has like how many, okay, so it does have like monthly podcast listening, like ages 12 through 34, but it just
Yeah.
gives like a general number.
Like, what's it say?
And so it has like from 2017 to 2020, and so like for ages 12 to 34, it says 49% of the population listened to podcasts
What?
in 2020.
Okay. And then do they have another age group?
35 to 54, and then 50.
And then what was that percentage?
40.
40. Okay. Do you have any idea how many people they sampled in those? Because if you did, that would be enough right there. You could compare those two demographics and say, is that statistically significantly different from each other? So you're comparing two population proportions, kind of like what you did in section 9.4. Usually though, if you can get there, my guess it's probably around 1,000 or 2,000 people they surveyed.
It has like an overall estimate on like the last few years.
Does it have a margin of error or not? Because that would be an also, like if it had a 3% margin of error, you could pretty much say it's about 1,000 people, and that'd be fine.
No.
If it's got a smaller margin of error, it's probably a big number. If it's a bigger margin of error, it's probably a smaller number.
It doesn't say anything.
Does it have a little footnote at the bottom?
No.
It cites.
I'm going back up to the top to see if it says.
Can you copy paste that link in the chat?
I can try sharing it.
Or share your screen? Yeah, that'd be great.
I have to remember.
Sometimes it matters what audience, obviously they're putting this stuff out for. A lot of times it's just for people are consuming it, but now that you've taken stats, well, hopefully you're asking a little more critical questions like, okay, who did you survey? How representative was it? How many people? What's the margin of error? Was there a bias? Right? So these are all the questions we need to start asking ourselves. And that's why if your ability to take a stat that you see on the internet, start tunneling down a little bit, you can help answer those questions.
I remember I did this with my
Oh, I need to promote you. I'm sorry. That's not. I gotta change. I gotta give you the ability to do this. Hold on. This is my bad. Sorry. All right. Now you should be able to see out your screen. Sorry about that. Now do you see it?
Yeah.
Cool.
Chrome tab. Okay, can you see that?
Yep. Very good. Cool. All right. There's the methodology. Yep.
Oh, there it is. I found it.
There it is. Yeah. It says right there. So it's a 1,502. So you've got your N, you've got your percentage. Now, is that for both surveys? Is that between both of them? You know what I'm saying? That was 12 and older.
Yeah.
And then what were the two stats you saw that you were comparing?
I'm gonna find that. Way at the bottom. They did a lot on this study.
Yeah. No? Very cool. Yeah, there's a lot of good questions you could ask with this stuff.
Podcasting. Okay. There's monthly. There it is. Right here.
Okay, very cool. And let's see here. So you've got the numbers right there. No, those are all percentages, aren't they? So you don't know how many.
Find the number.
Yeah, they don't give you like how many people out of that 1,500 were age, 12 to 34, right?
Yeah.
Scroll down a little bit more. I'm curious if they give it that for any of these. Okay. All right, go all the way to the bottom of the document. Okay. All right, go up a little bit. Let's see here.
Observations.
Yeah, I'll keep going up a little bit. So this is like their conclusions page based on what they found. Go up a little bit more. All right, keep going up. There we go.
So that's how many podcasts they've listened to in the last week.
Mm-hmm.
And then the average time.
Yeah, it doesn't give any breakout of how many were in each of that particular one, the categories, right?
Yeah, correct.
Which is too bad.
This should probably be like the closest.
U.S. population. Oh. So how about this? I don't think it'd be a crazy thing for you to infer this. If they're claiming this to be a representative sample of age 12 plus, essentially,
Yeah.
and they're saying that 37%, this is the age of monthly podcast listeners, 37% are, I don't know. You may have to do a little backwards thing here and find out, like, for instance, what percent of the US population is age 12 to 34? And then what percent is between 35 and 54, and what's 55 plus? So you might have to go to the US Census Bureau on that and just quickly find out. So let's say hypothetically, it's like, you know, age 20 to 34 is like 25%, age 35 to 54 is 35%, and age 55 plus is 30% or whatever, right?
Yeah.
Then what I would say is, you know what, we'll assume that this was a representative sample of that demographic. So then you're like, okay, if age 12 to 34 is 25% of the US, then assume 25% of that 1,500 people were in that category.
Okay.
I don't think that's, I mean, that's not perfect, but I mean, it gives you close, right? So
Yeah.
if you could do a little digging and find out what percentage of the population is in each of these age categories, and then infer that back to their 1,500 number.
Okay.
Does that make sense at all, or?
Yeah.
Okay. Like if hypothetically they're all like, it's not a third, a third, a third, because obviously there's people that are under the age of 12. So it's not going to be like, but maybe these groups are approximately the same. I don't know. So that'll be interesting. And then you could even cite the US Census on that to kind of and explain your methodology in your little write-up. Say, hey, found this. They surveyed 1,500 people. Here's the null hypothesis is that they were the same. They found these percentages to be different. And here's how I inferred those numbers. And you can just explain it.
Okay.
Cool?
Yes.
All right, you're very much on the right track. Yeah, this is a good source, got good data. Yeah, and I think you're on the right track. How's that sound?
It makes me feel much better about what I'm doing. Thank you.
Yeah, no, that's a really neat question, and some of those trends. And because you're going to link that source in your write-up too, and you know, you can even say, here's some other things found, you know, that you thought were cool.
Okay.
You know, there's something interesting there that you thought was. How's that sound?
Perfect.
Wonderful. I see we have, well, Mackenzie, I know you had to go. Did you have another question besides that tech issue?
No, I was just watching.
Okay, was that helpful to kind of hear all that?
Yeah.
Okay. But what are you doing for your project?
I'm trying to do screen time averages in teenagers.
Nice. And are you comparing it like today versus a decade ago? Or Iowa versus nation?
Yeah, I'm doing the US compared to Marion County teens, if that works. So
Yeah. And make sure if you're looking like average hours, you also need the standard deviation of that data.
Mhm.
Is that cool?
Yeah.
Very good. All right, that's a great question. Good job. And how about Bryn? Bryn's with us. Did you have any questions on your final project? I don't know if she can. The class I'm taking, the professor always says, loosen your mic. He's an elderly guy. He's awesome, but he always says that. Loosen your mic. Maybe Bryn can't hear me. Bryn, can you hear us? I'll put in the chat.
I'm on my way to a golf meet, otherwise I would talk.
Oh, okay, no worries. Were you just listening in, or did you have any quick questions?
Just listening in.
Okay, awesome. And I am recording this, and I'll post it later too, okay?
Okay, thank you.
All right, have fun.
Thank you.
All right. All right, any other, I mean, I could just go over a couple general things I noticed in the project. In general, a lot of people are going to pick means and proportions, which is totally cool. sometimes they're going to have a known proportion, and they'll just say, you know what, it's this proportion typically, and then I found this data set. How does that compare? They may find two separate data sets to compare those two means or proportions. That's another thing. A lot of times people struggle sometimes with what's the result. You can say, well, our p-value was 0.0001. We have strong evidence to reject the null hypothesis that blah, blah, blah are the same. We have significant evidence to say that there's an increase or decrease or whatever, just using that proper language when they're describing the result. Also with the confidence interval, like we're 95% confident, like we'll use, Katie will use yours. We're 95% confident the true difference in proportions between this age group and this age group is between, I don't know, -2 and -5% or something like that, or whatever it ends up being. And those confidence intervals should be there that essentially verify what the result was when you did your hypothesis test. But just using that language, we're 95% confident the true difference or the true proportion or the true mean, difference in the proportions, just using that vernacular. Now, I have the deadline of Tuesday of finals week, I believe, which is what, May?
Is it the 4th?
4th, yep. So I want everybody to have it done by the 4th, so we still have a couple days for people to read, listen to other people's videos, comment back. If you mess something up, you can fix it. So I'll give a little feedback. I'm going to give you a score. I'm going to score it in the rubric. And if somebody wants to, fix that stuff, they definitely can until the 6th, which is why I like everybody to have it done on the 4th, so we've got time to do that. If somebody submits it on the 6th, it was too late for anybody to see your results, and it's hard to, then you can't interact with people on the discussion board, and I can't really help you with your, get it better. So if you want to submit final projects, like let's say, Katie, you get you're like, oh, I'm good. I'm right. Go ahead and write it up, make your video, and submit it as soon as you want. And I think it's available, isn't it, on Blackboard?
I think so, yeah.
Yeah, I think it's available. The only thing I don't have open right now is the final exam.
Okay.
So that's the only thing left to even turn on. And I'll probably turn that on no earlier than Wednesday. Yeah, probably no earlier than Wednesday. But most people probably have some other things to be working on between now and then. Cool. All right. Well,
One more.
yeah, go ahead.
It's about
Yeah, go for it. Yeah.
goodness of fit. How do you
Yes.
find that on StatCrunch if you only have like one set of data? Like you only have, so like for our homework, we have like the days and then the number of births.
Yep.
So
So goodness of fit, in that case, typically those are like, our null hypothesis is that it would be the same every day, right? The same
Yeah.
number of births. So if, let's say you had 1,000 births, then it would be 1,000 divided by 7. That would be your expected value for those. Does that help?
yes.
And then you compare your number with what it was expected, find the difference, square it, divide by the expected, add all those up, or you can just use StatCrunch to do all that too. So
My question is, so you have like the number of births, but how would you get, which is your expected value,
Yours.
right?
Yep. So how
Then-
many total births were there?
And-
Let's say it's 1,000, whatever it is.
Yeah.
So 1,000 divided by 7 would
Yeah.
be the expected for each Monday, every day.
Okay.
That's the number you would use. In fact, when you do it on StatCrunch, it's got a box that says expected value is the same for all categories. They just click that box and it automatically figures that out.
Let me just. Okay, that makes more
Yeah.
sense.
Yeah. So like there's always this joke like, well, like think about it this way. Have you ever gone to like a Chinese restaurant and you get the little fortune cookies?
Yeah.
And they're like, well, oh, you were born here, so you must be like this, right? They try to associate your birthday with like your personality type and stuff,
Yeah.
which is completely hilarious. But like, or they might say, most CEOs are born in this month or whatever. And so you can do statistical analysis, see if there's any, is there really something going on there? what's funny is there is some like sports that are like that, like Major League Baseball players and hockey players and stuff have certain birth months. Why? Probably because their parents only had certain months of the year that they were going to have babies. So there's a higher proportion of them born in those months. And so that's the other thing is, are there certain times a year where more babies are born than others? The answer is yes. I'm sure the pandemic really put a monkey wrench into that too. So who knows? We might have a baby boom coming up here. Or it's already started, who knows? Yeah, that's always interesting stuff to look at. Like that's what happened after World War II. It's called the baby boom. Everybody came home from war and started having babies. So there's always really interesting questions to ask with that. The goodness of fit kind of example. Like rolling a die, is it a fair die? Well, you should have the same number of occurrences for each roll, right? But let's say you got a disproportionate number of threes. Okay, that's kind of weird. Then you could actually test it to see, okay, is that really weird statistically, or is it, explainable? Is that variation explainable? That's really what we're doing in stats, is trying to figure out, okay, we're observing something. Okay, could randomness explain that, or is there something else going on? That's about all that's really what we're trying to figure out. Like you're trying to figure out, if they're random, is this age actually wanting to do more than this age, or more podcasts or not? Our null hypothesis is, nope, they're going to be the same. But your observation would be like, oh no, there's a difference. The question is, it statistically different? Is it show there is something going on here? Now you can be wrong. And so if you reject the null and you're wrong, that's a type 1 error. If you fail to reject the null hypothesis and you were wrong, that's a type 2 error.
Okay.
I don't know if you remember that from our last test, but
Yeah.
anyway, thought I'd review that. But cool. And then the final exam is pretty much everything you've done from your previous exams, and then a little bit from these last few chapters. And so
Okay.
but you can
Will you
start
have-
reviewing that.
Will you have examples of that?
Yep.
Okay.
If you look in that folder, there's there's it's all free response, and you can see examples from like the last chapters and stuff like that. So
Okay.
and then so that's 50% of your final exam, and your project is the other 50% of your final exam.
Okay.
So yeah, usually everybody actually, if everybody's doing the project well and studies for their final, in general, it might bring their grade up a little bit.
Okay.
Ideally, that's what we'd like. So, all right. Well, thank you for your time. Did you have any other questions?
I think that's all.
Okay, that was excellent. Thank you for asking that. And like I said, I'll post this recording and see if
Okay.
anybody else has. I'm sure it's going to help some people. So thank you.
Yeah, thank you.